and welcome back to Elementary Algebra with Applications. I'm your instructor, Amy Fuchsteiner. Today we are going to take a look at what to do with formulas and substitutions, and then we're going to take a look at what's known as literal equations. I'm not going to spend a lot of time on formulas. I'm just going to go over a few of them with you. They are all listed in your textbook. But since not everyone has the same background, I'm going to make sure to point you to those formulas that you should know or should at least have had exposure to, and let you know which ones I'm not entirely sure you have had any kind of exposure to. So the first one is the formulas that are used for business. I'm not sure everybody's had these, so I'm going to go over them first. The first one is that the retail price of an item is based on that item's cost plus the markup. The textbook uses the abbreviation of R is equal to C plus M. This is the retail price. I lost it out. Retail price is equal to the cost of that item plus the markup. If you don't have any kind of exposure to business, you may not realize that what a business pays for an item is called its cost. And then the markup is any additional monies that they add to their cost before they sell it in a sort of consumer type situation. So Walmart, for example, may be selling a hula hoop for $2.99 for the Easter baskets, but it did not pay $2.99 for that hula hoop. You're probably lucky if Walmart paid 17 cents for it. And then the rest of that would be the markup. So 17 cents would be Walmart's cost. The markup would be the additional $2.82, right? The second business formula that you may not be familiar with is how to find profit. Profit is revenue minus costs. So the P here stands for profit, and that is the business's revenue minus the costs. So revenue is all of the money that the business brought in. So from the hula hoops and the candy in the aisle and any contracts that they may have with larger businesses, all of the money that they bring in is revenue. Whether or not that revenue is all pocketed depends upon an item's costs. So the costs in a business include such things as buying the hula hoops and buying the suckers and sodas and whatever you grab last minute in the aisle. But costs also include like overhead costs. Like, cost in this situation could include salaries and insurance and any liabilities and electrical bills, all of that. So profit is what is left after all of the bills are paid. So all the money comes in, you pay everything off, and what's left is profit. Most of the time, if you've watched a Shark Tank, you know that when they're asking about profit, they also want the salesperson or the business owner to have included their own salary in that. Are you making a profit? Why, yes. What are you paying yourself? I'm not. Then you're not making a profit. Shark Tank. All right. The third business formula is the one we will probably use the most. This is I is equal to PRT. This is your interest is equal to the principal times the rate times the time. Principal is the amount of an investment or loan. Rate is the percentage that is either paid or earned. Time is always in years. Interest is the sort of like the fee you pay for the privilege of borrowing money. You may have had experience with loans. If you have, you probably recognize that the better your credit, the less money you pay in fees. Those fees are sometimes called interest, and the better your credit, the lower your interest. All right? That's why I call interest the fee you pay for the privilege of borrowing money, because nobody has to borrow anybody money. All right, from science, We are going to use distance is equal to rate times time. Rate in this particular case is meant as the speed, so 55 miles per hour, 2 meters per second. All of these are rates. Distance is equal to the rate times the time. So if you've had a general science or physics course, you're probably a little bit familiar with this. If not, one of the ways that we do this is the distance to, Madison is 120 miles. And if you're traveling at 60 miles an hour, it should take you 2 hours. So 60, the rate, times the time of 2 hours. 60 times 2 gets you the 120 miles to Madison. All right. We also do temperature and Celsius, in Celsius and in Fahrenheit. So the conversion from Celsius to Fahrenheit. Celsius is 5/9 of the quantity Fahrenheit minus 32. Fahrenheit is 9/5 of Celsius. Figure out what that is first, and then add 32 to it. I just want to mention here that the conversion from Celsius to Fahrenheit is not a drop. It's not a linear drop. Just because it's 2 degrees at one particular temperature doesn't mean it's going to be a 2-degree difference at every temperature. For example, the boiling point in Celsius is 100 degrees Celsius. That's 212 degrees Fahrenheit. That's a difference in degrees of 112. However, 98.6 is the normal body temperature in Fahrenheit. That's our measure. But in Celsius, it's about 36 degrees. So that's only a difference of 60. Okay. The difference between the two is not consistent. So you will need to calculate it most of the time. All right. The formulas from geometry, there are a plethora. If you're not familiar with that word, that means there are a lot. These formulas from geometry you will want to keep handy. We do make some assumptions about your familiarity with most of these formulas, perimeter in particular. If you do not have the perimeter formulas sort of memorized, or at least forefront, you're going to need to practice them a little bit to get them there. The perimeter of a rectangle is 2 lengths plus 2 widths. For a square, since all sides are the same, that will be 4 times the side. In order to find the perimeter or outside of a triangle, you will simply add up the sides A, B, and C. The area formulas, we have an expectation that you are familiar with the area formula for a rectangle, a square, a triangle, and a trapezoid. This doesn't mean that I'm going to make you memorize them, but you should have them available to you, and the work will go a lot faster if you do already know them. For circles, we do expect that you are familiar with a diameter, a radius, a circumference, and an area. As a reminder, the diameter is across the center of the circle. It is found by knowing the measure of a radius. A radius is from the center of a circle to an edge, and if you double it, you get the diameter. So the diameter is 2 radii. That means that the radius would be half the length of a diameter. Circumference is the perimeter or the outside of the circle. The area of the circle is the enclosed region. So perimeter goes around the rim. Rim is in perimeter. In a circle, we call that circumference. So there's a little bit of a there. The area is the enclosed section. So when we talk about the area of something, we're talking about what's inside or what's enclosed, all right, on a flat drawing. Because we also do take into account some formulas from volume, and those formulas from volume are 3 dimensions. This is sometimes called a capacity, or the amount that you could fill. A rectangular solid is just another word for a box. So if we're talking about a box, we're talking about a rectangular solid. A cube is a box where all sides are equal. That's why it's S cubed, because your length, your width, and your height are all the same. The volume for a sphere is 4/3 pi r cubed. The volume for a cylinder is pi r squared times the height. The cone is 1/3 pi r squared times the height. And the pyramid is 1/3 the area of the base times the height. So there's a lot of formulas here. Let's try a couple. Let's see what we've got here. All right. Ooh, there's a lot. Music department has a fundraiser. There we go. The fruit cost, let's see. That should be a T. There you go. This seems a little. All right, the fruit costs $5,632. So the music department bought fruit for a fundraiser in the amount of $5,632. They sold the fruit for $7,212. So they managed to bring in $7,212. How much profit? How much profit did they make? This is a business formula. We're asking you to recognize that the profit would be the revenue minus the cost. The revenue is all the money they brought in. The cost is what they paid for it. So that revenue would be $7,212 minus $5,632. Let's see. 7,212 minus 5,632 is 1,580. So what was their profit? Their profit was $1,580. Okay, let's try another one. Marcy takes out a loan. Whoops. Of, let's say, $32,000 at 8% interest for 6 years. Okay, so we're going to determine her repayment. If we're going to determine her repayment, that's going to be the loan plus the interest. Okay, so her loan was $32,000. Her interest is the principal times the rate times the time. Now, do we know the principal? That was $32,000. Her interest rate is 8%, 0.08, and the time on the loan in years is 6. So I need to figure out what 32,000 times 8% times 6 years. So this bit is 15,360. So I need to add that interest to the initial loan. And I get $47,360. That's a lot. Why would anybody do that? Well, usually you do that. Usually I can speak as as somebody who's taken out a loan, you take it because now you can pay in monthly installments. So now you can pay once a month for 6 years. And if we were going to do monthly installments on this, just because I'm curious, we're going to take the 47,360. We're going to divide that by 6. Whoops. Divide by 6. Divide by 6. 47,360 divided by 6. There we go. And then I'm going to divide this by 12 because I'll make 12 payments. And now you can see the payment is $657. So I might not have been able to have afforded $32,000 right out of the gate, but I can afford a $657 payment. Maybe I can, maybe I can't. But you can see the difference. Like just in thinking about the amount of money, I don't want to think about 32,000, but I can think about like less than 700. And so then I can decide whether or not that's feasible for me to pay, and I can move on from there. Okay. One more. I wanted to do one geometry formula at least. So I'm going to take a minute. I'm going to flip this over, and I am going to do a geometry formula. I think I'm probably going to do, should we do a volume one? Let's do a cone. So let's find the volume. So a cone is basically that. It's a cone. Okay, when you look at, I forgot my E. When you look at a cone, there's usually the center of a circle, and then they'll tell you how high or tall it is. So I'm going to say this is, let's say, that's a 2-inch cone, and let's say that it is 6 inches high. We'll make it an ice cream cone just because. So here we have an ice cream cone, maybe from the pearl. Oh, that's a good thing. So we're going to find the volume of the cone from the pearl. We've got a cone that has a 2-inch radius, right? This is our radius. And this 6 inches would be our height. We're going to start with the formula for the volume of a cone, which is 1/3 pi r squared times height. Now, I know the volume of a cone because I teach mathematics. I don't necessarily expect that you would know the volume of a cone right off the bat, but you should have the different formulas available to you. Take and put them all on the sheet in your notebook or your notes or whatever it is you're doing, okay? The other thing that you will need to know is what the R stands for and what the H stands for. The R is for the radius. The H is for the height. Now, pro tip. Anything with a circle, whether it's perimeter or area or volume, if there is a circle in that shape, there is going to be a pi in the formula. That's just the way it works. Pi is permanently tied to circles. It is a relationship that exists in a circle. It's defined by a circle. Pi is defined as circumference over diameter. This is not a geometry class, but that's the truth. Pi is defined as the circumference of a circle divided by its diameter. So anytime you see a circle, there is going to be a pi in the formulas that you use. Okay? All right. Now, volume starts with V. So this is going to be 1/3 times pi times my radius, which is 2 squared, multiplied by my height of 6. Now, if you have a calculator that you're familiar with, you can go ahead, and my advice would be to type everything in here, leaving out that pi. So I'm going to do 1/3 times 2 squared times 6. And my calculator will give me what that is. This is 8 pi. This is known as an exact answer. We talked, I believe, a little bit earlier about how pi is 3 or 3.14 or 3.14159. So since pi can be rounded to many different variables, 8 pi is known as an exact answer. On your calculator, you can now do 8 times pi, and this will give you 25.132741123, and it will keep going. And then you just need to round to whatever place value they want. So I'm going to do 25.1, and these will be inches cubed because those were inches. All right. So basically for this with formulas, you're just doing what we traditionally called plug and chug. In other words, you're plugging in answers and plugging in numbers and chugging out answers. There we go, plug and chug. All right, the fourth section. This is a little bit harder. This is known as literal equations. We're going to solve for a specific variable. We want to use some of the formulas that we have, and we're going to rearrange them. If you've taken a science class in the last few years, you may have done this in your science class previously. If not, it's okay. I'll show you some of the pitfalls here and some of the reasons I love them and some of the reasons you hate them. All right, so here we go. We know that the perimeter of a rectangle is 2 lengths plus 2 widths. Right? That's 2 lengths plus 2 widths. But what if we have to solve this for the W? So what if we want to isolate this for the W? The W is what we want to have. The W is what we want to get alone. Now, we're going to rearrange this formula. We're essentially going to isolate W. This is also known as solving for W. Here's the kicker. I'm not going to get a numerical answer. Like, I'm not going to be able to tell you that W is 16. What I'm going to do is I'm going to take this mess, this P plus 2L, P is equal to 2L plus 2W, and I'm going to rearrange it so that the W is clean and the mess is on the other side. Have you ever tried to organize a closet and then when you turn around, the room is a mess? That's kind of what we're going to do. We are going to take this W and we are going to clean up everything around it so it stands alone. And then the other side is going to be a mess. We'll clean up as best we can, but we're just sort of reorg. We're just doing a reorg. That's it. So how do we do this? Well, left side, right side, right? I've got 2 times W plus a 2L. I want to divide by 2, but the first thing I'm going to do actually is just move that 2L over. I'm going to get this 2W alone, so I'm going to subtract 2L from both sides. Right? It was positive on this side, so I need to subtract it from both. That's going to give me a P minus 2L. This is the bit I always loved because P's and L's don't mix. I can't combine them. So all I can do is rewrite it as P minus 2L. I loved that I literally did not have to think about what number that was going to be. But I totally get that some people hate this because they want it to be a number. This is P minus 2L, and I can't do anything more with it. What's left on the right side is the 2W. I'm trying to isolate the W. Is the W alone all by itself yet? Nope. It's being multiplied by 2. So in order to undo the multiplication by 2, I need to divide by 2. And if I divide by 2 on the right side, I have to divide by 2 on the left side. But here's the kicker. I got to divide the whole thing by 2. Not just one part, the whole thing. Again, this is the part I loved because this is just P minus 2L over 2. Okay? What's left on the right side is a W. 2 over 2 is 1. That's a W. That's it. That's all she wrote. I can't do any more. Well, there is one thing I could do more. And sometimes you have to do it and sometimes you don't. But we do sort of need to recognize that P minus 2L could be simplified. I could take this all over 2 and split it right? I could split it and put it underneath each term, which would then give me P over 2 minus L equals W. Because those 2's would cancel and give me an L. So this is okay. Actually, either one, this guy's okay and this guy's okay. It just sort of depends upon your instructor and the textbook, whether or not it's taking alternate formats. Because basically, I got W alone on one side. I put everything else, I cleaned out the closet. There's only W left. Everything else is in the room. How I arrange it in the room, it's like moving a shelf under a window. Yeah, it's like there's not a whole lot of difference. If there's an obvious, like, way to make it better, then okay, but no. All right, let's try another one. Let's try volume is equal to length times width times height. And we're going to solve this for L. Okay? That means we're going to isolate the L. So looking at my equation, I'm going to drop my line. I'm going to circle my L. What's happening to the L? L is being multiplied by a W and an H. How do I undo multiplication? I undo multiplication with division. And since order wouldn't matter, I could group that WH together and just divide by both at the same time, which is efficient. And that's going to cancel the W and H on the right side and just leave me with an L. And then on the left side, I will have volume over W times H. The L is isolated. I have moved everything else out of the closet. It's all in the room. It's all together. I'm done. There's not a whole lot else I can do here. Okay. I'm trying to find a hard one. And I'm not seeing a whole lot of hard, well, I don't think they're hard yet. You might have to ask me about them yet. All right, so there's a second one. Yeah. Should we try a third one? Let's try one last one. Let's try volume. No, let's not. Let's do area is 1/2 height B1 plus B2. This is the area formula for a trapezoid. It's one of my favorite formulas. So let's solve this for B sub 1. So when you're looking at the area formula of a trapezoid, B1 and B2 stand for the first base and the second base. And in a trapezoid, B1 and B2 are the sides that are parallel to each other, the sides that line up with each other, run parallel. So, and then the height is the distance between those two bases. So you find the area of a trapezoid by doing 1/2 of that height and then multiplying it by the sum of the bases. So how do we solve this for B1? Okay. This one's a little tough. I'll agree. This one's a little tough. But do you see how it has a fraction? See how it's got the 1/2? I would multiply both sides by 2 first. Because when you multiply by 2, that's going to cancel with that 1/2. 1/2 of 2 is 1, or 2 times 1/2 is 1. And that's going to leave me with a 2a. Okay. Oh, I didn't circle my B1. I'm looking for my B1. So B1 is inside of those parentheses, so it's protected. Nothing can happen to B1 until you eliminate the parentheses. It's like it's underneath the covers, and everything you do outside of the parentheses will not affect it until you take those parentheses off. then you got to start worrying. So I leave those parentheses on as long as I can. Right? Inside the parentheses, B is being added to B2. Outside the parentheses, it's still being multiplied by H. So since that's outside the parentheses, I can divide both sides by H. And that's not going to affect the B1 because the B1 is still inside the parentheses. It's still under the covers. Nothing is going to affect it yet. That leaves me with 2A over H is equal to, and now in parentheses, I have B1 plus B2. The problem is, at this point, I don't need the parentheses. They're redundant. They're not doing anything. There's nothing left on that side except the B2 it's hiding with. So I'm going to rewrite this as 2A over H is equal to B1 plus B2. What are we looking for? What are we trying to isolate on this side? The B2. And because we're trying to isolate that B1, it's being added to B2. So I'm going to subtract B2. And if I subtract that from the right side, I must also subtract it from the left side. Now again, you might want to combine all this. You cannot. It is literally two parts. It is 2A over H minus B2 is equal to B1. Notice I did not put the minus B2 in the top. It's not in the top. It's separate. All of this goes together. This is one sort of messy thing. And from all of that, I'm going to subtract B2. So I have 2A over H minus this B2 thing. It's going to equal the B1. B1 is isolated. It is all alone on this side. Other side is a mess, but that's okay. I'm done. Okay. That's it for 2.4 today. We will take a look at some word problems in our next visit. And if you need anything in the meantime, please don't hesitate to reach out. Thanks.